Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back here for the 6C33C. We got the fab work done on the chassis, got the switch installed, got the choke done, got the speaker jacks installed, got some of that wired up. I stopped at the point where you could still see what I was doing, so I'm going to go over wiring up the power supply. So let's get busy putting this amp together. Okay, so we got some more work done on the power supply. Since the last video, I installed the two speaker jacks here in the back. We got the IC connector installed here. This is the safety ground that goes from the IC socket to the chassis of the amplifier, and it's double nutted here with some keeps nuts on a little solder lug with the powder coating scraped off the inside, so we got a really good ground connection there. And the purpose of this is so that the metal chassis itself is solidly grounded to the outlet in case anything happens and there's some kind of a short or something gets, trying to make the chassis itself hot, it'll blow the fuse. So we've got the black lead from the transformer hooked up to this lower terminal on the IC socket. Let me flip this up a little bit so we can see this a little better. So this lower terminal goes straight to the transformer. This goes to the switch. That goes to the ground. So then we have this twisted pair of wires here that we've got a splice here with some heat shrink tubing over it that goes to this pigtail that comes off the switch. These two wires are going to go to the LED power, which we'll deal with in a future segment. But those are for the angel eye illumination around the switch that tells you that the power's on. So let's look at the power supply in more detail. We have the high voltage AC that comes to these two terminals that go through these two diodes to our rectified DC output. These two terminals are tied together with a little jumper here. So someone had a good question in the comments, why are you using a half-wave rectifier? That's not what this is. And I know a lot of people are used to seeing a bridge rectifier. This is what's called a full-wave rectifier, and that's what a tube rectifier is doing as well. It's just a different way of getting to the same place. A bridge rectifier takes the AC across the whole winding and then uses 4 diodes to get your DC here, your complete DC wave. Because a half wave is really choppy. A full wave takes one side of the transformer, then the other side of the transformer, and then the center tap is grounded. And so on an oscilloscope, you have the same looking waveform as you would with a bridge rectifier. But we're using the transformer differently, and we're using 2 diodes instead of 4. Now we could use a lower voltage transformer that has a higher current rating and then use a bridge rectifier, but the transformer I found likely was designed for use with a tube rectification, and so it was a higher voltage at the milliamp we needed, and so we're using a full wave rectification. So then the next thing we got going on, this is the raw DC. We have our first capacitor, which is a 33 UF, and one of the reasons I'm using a smaller one is we're not trying to do all the ripple reduction on this first capacitor, which puts a lot of strain on the capacitor. It also puts a lot of load on the transformer, not only in initial power up, but just in operation. And I'll put a link to a video below about why that happens. But I'm not going to go into all that today, but we're going to use a 33 UF for this first cap. And then it goes, this wire here goes over to the choke, which is sitting right here. And then the other wire comes back. Let's go over here, see. See, there's our choke right there. And then other wire comes back. This is the voltage after the choke. We're going to have another capacitor that goes from here to here, which is going to be this guy like this. It's going to go across those two leads, just like that. So then this wire comes over to the bottom of this 50 ohm resistor, and then this wire comes from the top of this resistor down and over to this terminal. And that's our RC, or resistor capacitor filter. This is the second filter in the power supply. So then finally we're going to have another capacitor that's going to sit across here like this between this terminal and ground. That'll be the second filtering capacitor. And both of these are, as you can see, they're 220 UF, 350 volt, 10C rated axial capacitors. So we'll have this capacitor. So again, AC here, DC on this terminal here. These two are tied together. This is our first cap. This goes over to our choke, comes out of the choke to this terminal, which has a capacitor from here to here. Then it goes through our resistor over here, comes back to this terminal, have another cap that goes from here to ground. These two are tied together with this little jumper. And then this will be our final filtered DC. This is our positive lead to the output transformer. This is going to be run over here, and it's going to be hooked up to this point right there. That's our output of the power supply. And then again, this is the output transformer in and out leads for the plate of the tube. And then over here you can see we have the other lead for the output transformer going over to the plate of the tube. And then we still have the speaker leads to hook up. We've got, this is the positive that I've already soldered on. I left this one off so I could, work inside the amp a little bit. This one's going to connect there to the negative. We also have a negative lead that goes from here down to our star ground point, and that gets the speaker outputs connected. So one of the things that I've done in my previous amps, I've used a film capacitor for this first capacitor, and we're going to try something different. I have used electrolytic caps before on a couple of my smaller amps, and I want to test this sonic difference between using this electrolytic cap for the first cap in the power supply, and then later I've designed this so it's really easy to unsolder this lug and just kind of tilt this capacitor over out of the way a little bit. And then I left room here to put one of these Solene film caps right here. There's room to put a clamp, mount this right here, and then I can run this lead to this terminal, and then run, add some wire to this and run it over to here, and see if I hear a difference. And I'm not sure whether I will or not. I was kind of shocked the last time I did a first cap in the power supply change to that WEMA cap, which I did a video on. It made a huge difference. And the same may be the case here. And I know some of you folks are like, well, why don't you just breadboard this stuff? Well, for one thing, if I get this thing all spread apart on my bench, breadboarding it, there's no way for me to then take it upstairs to my listening space in the same room with the same room treatment on the same speakers and listen to it. And I know some people, AB and listen to breadboarding stuff in their workshop or whatever, but to me, I think that the room and the speaker placement and all that changes so much that it would be difficult for me to really hear what changes are making in a breadboarded situation. And that's just me. And I don't really have a problem coming back inside the amp and using a prototype like this basically as a breadboard. Plus, to me, it feels safer than having all that high voltage just exposed on wires and jumpers going all over the bench. So, this is just how I choose to do it. I know some people love breadboarding, and hey, if you want to breadboard stuff, more power to you. Go for it. So, from here, like I said, I've got the power switch wired up. I think what I'm going to do at this point is I'm going to put these caps in. Oh yeah, and then the other thing that I still need to do is I need to put the bleeder resistor, which is going to go from this terminal right here to ground. And I normally use like a 470K, so I need to kind of sneak that guy in here before I get to soldering these caps in. And what that resistor does is when you turn the power off, especially at this kind of stage of the build where you don't have any load on the output, when you turn the amp off, it gives a path to ground for the capacitors to ground and drain their energy. If not, they'll just hold the energy for sometimes hours, which is not a safe thing. And it would also be the same case is if somebody powered up the amp with no tubes in it and then turn it off, the caps would have all that energy stored in them. And even after the tubes draw down much of the current in the caps, there's still some voltage left, and I found it seems to kind of stabilize the power supply as well, having just a little bit of load on it. And I don't like putting too low a resistor because I feel like that just puts more strain on the system and builds heat and all that kind of stuff. So anyway, I need to get that bleeder resistor installed, and then we will get the caps installed. And like I said, I'm going to hook this up. So after I do that, I'm going to power up the amp with the tube in it and see how the heater works, make sure that all that's good. And I've read that it's good to burn in these tubes before you actually use them. And some people have read put them in an oven. I like the idea of just running them with just the heater on them for a few hours to kind of let the tubes settle down to where it's going to be in the long term. And I can kind of get an idea how much heat it's going to make. The other thing is one of the viewers questioned where I put the output transformer related to the power transformer. Let me show you what that looks like. And I'm laying this out a little differently than I've done some of my other amps. I got some comments about, one guy was really sent me a nasty email about, you have no idea what you're doing. You've got the transformers oriented all wrong. You shouldn't even be making videos. I'm like, oh my God. Just, give me a break. This is a prototype. This is the power transformer. This is the output transformer. Normally, I would turn the output transformer 90 degrees to the power transformer. But this is kind of an experiment. I've read that this is the case, but I'm not sure if it's true or not. So we're going to find out. This is one plane. This is another plane. They are offset. The laminations are not lined up. So if this is going to make noise, it'll make noise when I put the tube in and when I power up the amp with the output transformer hooked up to the speaker jacks. And if it's quiet, then it's not going to be noisy because of this layout in the future. If it makes noise at this point, obviously this doesn't work, and we'll need to rotate this transformer. Now, one thing I was made aware of, and if you look at most amps, they never have the laminations, like the magnetic flux, lined up with the tube. Because again, not sure if it's true or not, but I've read that the magnetic flux can impact the electrons flowing through the tube. So that's why I wanted to put it in this direction. And who knows, I may rotate, this transformer and this one and the choke, but I didn't want to line up the laminations with the choke with the output transformer. And I don't want to have the laminations of this choke lined up with the laminations of this. And so that's why I laid them out in this orientation. Was, again, if I turn this, then these two will be directly in line, which is a bad thing because this is going to the plate of the sensitive input tube. So then I would have to rotate this one. Well, then if I rotate this one, it'd be lined up with the laminations on this because they'd be like this. So then I got to rotate that. And if I rotate this, then that possibly could impact the electron flow through the tube, which is another thing that I read in one of the tube amp design books. And so this is why I went with this orientation, and I think it's a fairly simple test now to, again, we can put the tube in, power the amp up with no voltage going across the plate, and then listen for hum on the output, and if it's quiet, it's going to be quiet. So the last thing I want to show you, the other thing that I've read about these tubes is they don't like having voltage put across them until the heaters have had a chance to warm the cathodes up fully. And again, I've read people saying 5 minutes, some people say 15 minutes. And so I was concerned about putting a switch on the high voltage side of the amp. The switch would be somewhere on the back of the amp, which would make it hard to get to, and it would be easy to forget and that sort of thing. So what I'm thinking about doing is putting a switch up here in the side, and this will be the outboard side of the amp. And I'm not sure if I'm going to use a toggle switch or if I'm going to use a rocker switch or something here on the side and run the cathode through that switch before it goes to the cathode resistor. And that way I can open the circuit on the tube on the cathode side where we have lower voltage, and then use a DP-DT switch that I could use the other side of the switch to power up an LED that goes on the top of the amp, so that when you power the amp on, I'll flip this over again, that LED could be anywhere up here in the top of the amp, so that when you power the amp on, if this switch is not turned off, you'll see the LED on before things really get going in the amp, and you can go whoops and flip that off. And it'll also be an indicator that the tube has the circuit completed, so the current's running through the tube or not. And that way you can open the cathode circuit, let the tube warm up, and then flip that switch to complete the circuit for the current running through the output tube. So leave in the comments what you think about that idea. Because one of the things I was concerned about, I've seen some of them that just have dual switches and it's on the high voltage side, and trying to figure out, remembering which way you flip the switches and the sequence for turning off the amp and turning it on. And it may be the kind of thing I just have to get in the habit of, you flip that switch off first and then this one. And then when you power on the amp, you flip this one on. And then after 15 minutes, you click that one on and you listen to it. And I'm not even sure if that's really a thing with these tubes, but I've read enough people saying that I believe that it may be true. So that's where we are. Oh, and here's the little screen that I put in the back to ventilate the inside of the amp off of that 50 ohm resistor in the power supply. So I think that turned out nice. So anyway, this looks like a great place to wrap up this video. As you can see, got a lot done. About ready to power this thing up and see what the heaters are going to do. Make sure that we don't have any noise on the output jack, like I talked about. If we do, hey, we have to rebuild and repunt and kind of redo some of this and get all that to work. And that's what we're doing here, is trying to learn. And some of this is learning what you can get away with and what you can't get away with. And hey, that's life's kind of like that sometimes, right? So here we are. And I know, like I said, some of you guys like breadboarding. That's just not my style. You've seen me build a bunch of amps like this. And I do want to kind of add that I know I say, yeah, don't build this because I don't know what this is going to do. I've got a pretty good idea what's going to happen. Is this thing going to sound good? I don't know. Is this driver going to work like I hope? Or is this tube that I've picked out to replace the D3A going to be too microphonic? Like, I know I could go buy a pair of D3As and this would work. I trust that DHT Rob designed this thing in a way that this will work with the minor changes that I've made, because I haven't changed anything that drastically, especially on the driver section. But I am not going to spend $400 on a pair of driver tubes. And yeah, I know somebody's going to say, I found a pair of D3As at a thrift store for $5 or at a yard sale. That's not going to happen for me. And so I'm trying to find some affordable tubes to use in this amp. And again, we're not using, $2,000 output transformers. And we're not using, super high-end plate choke. This is all like Hammond and Edcore iron and stuff. So I'm trying to find a way to do this on a budget. And that's kind of what we do on this channel. If you want to build this thing with, $3,000 worth of iron, go for it. But again, wait until I'm done. I've showed you the schematic as I go along so you can understand and follow along with what I'm doing. And I know some people will record these videos as they go along and then they don't publish them until they're all finished. And you guys have been following my channel. I don't roll like that. And I show you, hey, this didn't work. I know one amp in particular. We had to change a bunch of stuff. That budget 300B amp, that was the one. It didn't work good at all. And so y'all watched my thought process as I worked through the amplifier. And we're going to do the same thing on this, which I hope is a learning experience for you guys to watch me fix stuff. And so I want to show you warts and all. And I don't want to be one of those YouTubers that pretends like I never make mistakes, because that is not what's going on here. So anyway, hope you're enjoying this content. If you are, please subscribe to the channel. Please like the video. Thanks to all you Patreon folks. I really appreciate your support. Plus just folks that watch my channel. I really appreciate y'all tuning in, watching this stuff, and we're going to get this thing finished up. We're actually pretty close. And I know this may not look like it, but I consider this about 80% done. Oh, and do leave in the comments what you think about the cathode switch for the output tube, so you can turn on and off the current going through the tube until it warms up. I think that makes sense to me. And, I may have to put a cap across it to make sure that it doesn't like arc or the point stick or something. But yeah, I think that makes a lot of sense to me. So anyway, till the next video, have a nice day.